Okay, we have been talking about in the past about quantitative data. That was data that could be measured that was measured in a quantitative or numerical matter. And we custom BS'd it to display and describe it. Now we're going to talk about categorical or quantitative data. And that is data used to describe an attribute like color or smell or and things of that nature. As a result, we cannot cuss and BS categorical data because order doesn't matter. Who's to say that blue comes before brown, which comes before pink? Who knows what the order should be on that? All right. Now, I said that qualitative or categorical data is not numerical, but the fact of the matter is sometimes we use numbers for categorical data. For instance, when you order something from Amazon, it's likely to have a numerical code. So it's like, oh, you brought product number 347921, and that tells them something. Or we might even say that with gender for male and female. You might assign males a 0 and a female a 1. Well, maybe that is numerical because, I mean, obviously guys are 0s and girls are number 1. If you don't get that straight, guys, you're going to have a problem the rest of your life. But in all seriousness, you don't know what, you don't have an order to that. So that's not to say that you can't make graphs of qualitative data, because absolutely you can. But the order won't matter in the graph. So scenario 1 says 35 students were asked to choose their favorite fall sports. The selection were as follows: swimming, basketball, football, tennis, volleyball, and cross country. And we have 3 dot plots recording that. And we have, 4 that like swimming, 8 basketball, 12 football, 3 tennis, 6 volleyball, and 2 cross country. And I look at those and I'm like, which one's right? They all look completely different. I have one that's kind of all over the place. I have one that looks like it might be skewed to the left. I have another skewed to the right. And it turns out they're all correct. And they're all correct because the order didn't matter in that consequence. Least to greatest, great to the least, or alphabetical. It doesn't really much matter how you put it together, or just randomly, because the order doesn't matter, so you cannot cuss and BS. And that's the biggest thing to get out of that. All right. If you turn this into a bar chart, all right, if you turn this into a bar chart, and a bar chart is slightly different than a histogram. If you turn it into a bar chart, make sure the bars don't touch. Why? Because one doesn't go to the next. They're separated, so they should be separated. All right. So bar charts. Here's a talk. This describes how to do them. You can read that yourself. We can display them as frequencies or percents, in which case it'd be a relative frequency percent. 50% of the people chose football or something like that. The bar chart versus a histogram. First off, histograms and bar charts look alike, but histograms display quantitative data. Bar charts do not. Because histograms are quantitative and order matters, the bars should touch or can touch. They should not touch. Once again, a bar chart, they should not touch because that's qualitative data. Pie charts can be used for both quantitative and categorical data. Both quantitative and qualitative can use pie charts because they report relative frequencies, and once again, they do not show order. And then we have segmented bar charts, which is a bar chart in which each column is divided into segments representing a percentage or proportion of that segment's representation in the population. We will look at that in just a moment. These are relative frequencies, and they do not provide insight as to the number and size of the sample. So the relative frequencies, I don't tell you what the number and size of the sample is, and each bar will be the same height at 100%. However, within the bar, the segments can differ substantially. We're going to introduce very briefly the concept of independence, and we're going to talk more about that as we go along. Independence means that one event does not impact the other. That's in probability. If categories are independent, then they must be proportional. In other words, it didn't have an impact. And like I said, we're going to develop this throughout our discussion on categorical variables. And that'll be in a following video. So the following table provides the results which relates a person's IQ to a person's dominant hand, whether they're left-handed or right-handed. And the table is illustrative of the proportional nature of independent categories. So we have right-handed, and in this case, we have 190 people who are right-handed with a high IQ out of the 1,900 in the population who were sampled. We have 10 left-handed people with high IQ out of 100. All right, notice the table sums up vertically and horizontally. 190 plus 10 is 200, so 200 people had IQ, and 1,800 people had normal IQ, and there you go. But if I take the 190 and divide it by 1,900, I get 10%. So 10% of right-handed people had a high IQ. Then if I go 10% of 100, I find out that 10% of left-handed people have high IQ, and 200 out of 2,000, 10% of the population had IQ. Because of that, I can say that my variables are dominant hand, and my variables are IQ level. IQ level and dominant hand are independent, because it doesn't matter whether you're left-handed or right-handed, it's proportional in nature, okay? So remember the proportionality, that if independent, things are proportional. All right, so just gonna look at a pie chart and compare it to a bar chart. All right, so in this case, a pie chart represents a 2017 Pew Research poll of political affiliation by race, all right? And we say, okay, we have this 2% of the Asian population are other. We see that 44% of the Asian population is Democrat, 42% are independent, and 12% are Republican. We see that on the black, we have 3% are other, 67% are Democrat, 27% are independent, and 3% are Republican. Hispanic, we're seeing that 37% are independent, 43% are Democrat, 6% other, 14% Republican. And if they're white, 30% are Republican, 4% are other, 26% are Democrat, and 37% are independent. So here's a bar chart displaying that same information. And it doesn't look very substantially different. I mean, it looks different, but you can see that all the information is there. And once again, order didn't matter, although within each subgroup, you should follow the same order as you have for the other subgroups. That's about it. But then we go to a segmented bar chart presenting the same information. Notice that every single bar is set to 100%. And when we look at this, we go, okay, there's that 67% that are black that are Democrat versus the 26% that are white that are Democrat, okay? So there's your comparison there. And then the first question is, can we say that there are more than twice as many black Democrats as there are black independents? Well, independents was 27%, and within that column, 67 is more than twice 27. So yes, we can say that. Can we say there are twice as many black Democrats as there are white Republicans? All right, so white Republicans, we sat there and go, okay, 33% of the Republicans were white, 33% of whites are Republican, and 67 is more than twice as much. So can we make the claim? And the answer is no. And that's because we don't know the population size. There might only be 20 million of one and 100 million of the other. So it could be true, or it might not be true. We just don't know the population size. Okay, so we don't know, because it's not within the same column, we can't say it. Can we say that the number of Hispanic independents is about the same as the number of white independents? Once again, it's not in the same column, so we don't know the population size of the Hispanics and the whites. And because we don't know the population size, we can't make that comparison. We can only talk about proportions. The only time we can make the comparison is when we do it within the column. All right. The only time we can talk about numbers is when we do it within a column. We can talk about proportions across columns. We can't talk about number. All right. Does a political affiliation appear to be related to race? Well, if they were independent, then all these segments would be the same. When I look at them, these segments are not the same. And because they are not the same, we can say the party affiliation appears to be related to race. In other words, race and party affiliation are not independent. There appears to be a relationship between race and party affiliation. Okay?